When it comes to graphing quadratics, we've got a few different forms. Vertex form is one of the most friendly to graph. So let's talk about what that looks like. In this example, we've got a quadratic in vertex form, and I know it's in vertex form because there is only one x value, and that x is being raised to the power of 2. So basically, if I were to strip away any adding, subtracting, multiplying, or dividing, I would get rid of this -2, the -3, and the +5, and I would be left with y equals x, and then there's that exponent on my x to the power of 2. So this tells me that this is a quadratic, and because there's only one x in the question, I can use transformations from vertex form. There's a couple ways to graph from vertex form. The first is to just look at your equation and find your vertex and then create a table and graph. The second is transformations. And transformations is extremely important to know because as you move forward in math, you're going to see that method of transformations come up with much more complicated graphs where creating a table isn't really an option. So we'll do both methods here. The first is to, again, find the vertex and then make a table from there. So my vertex form is ax minus h squared plus k, where my vertex is the point h comma k. One thing to notice, this h value is going to be the opposite of whatever is in the parentheses with your x. Then my k, I just take the value that's on the end. So if I were to rewrite my equation that I'm given using this, we would see that y equals -2, x minus, and then the number that we're subtracting is a 3. So that means my h is 3. Squared plus, and then the number that we're adding onto the end is that 5. So my h is 3 and my k is 5, telling me that my vertex is the point 3, 5. So even though there's a -3 in the parentheses, my x value is a +3. And then that +5 on the outside stays positive and gives me my y value of my vertex. So I just found the vertex, and that is in the middle of my graph. So if I'm making a table, let me just put that in the middle of my table, and then I'll find a couple points below and a couple points above. So let me plug in x is 2 and 1, and then 4 and 5. Something that you're going to notice if you do it this way is that the x values on either side of your vertex, they are going to give you the same output, and that goes back to the fact that parabolas are symmetric. So if we're going equal increments away from your vertex, you're going to get out the same y values. What I'm going to do from here is just take these x values and plug them in and see what y values I get out. I plugged in 1, I got -3. Remember, parabolas are symmetric, and I chose to create my table so that I went equal increments away from my vertex. So that means 2 units to the left of my vertex is going to give me the same output as 2 units to the right of my vertex. So if I plug in a 5, I'm going to get out that same output of -3. Let me go ahead and plug in my next x value of 2. So when I plugged in a 2, I got out 3, and again, I created my table so that we would be symmetric, and my 4 is also going to give me a 3. So my table is complete. Now I just need to create myself a coordinate plane, throw these onto the graph, and sketch my graph. My first point is 1, -3, 2, 3, 3, 5, 4, 3, and 5, -3. Connect the dots. You'll notice that you have a downward facing parabola with a maximum value of 5, and that is your graph. Now, if you were to do this using transformations, you're going to have the same outcome, but the process is going to be a little bit different. So let me show you what that would look like. Let's go back to our parent function. Remember we said that our parent function was y equals x squared, and that just comes from taking away any adding, subtracting, multiplying, dividing. So the -2 goes away, the -3 and the 5, and all you're left with is this x, and it is being squared. So my parent function is x squared. I'll create a table for that parent function. Usually we just plug in the values -2, -1, 0, 1, 2. If I plug those in for x, all I'm doing is squaring them to get y, so I end up with these y values. But now we're going to apply transformations. When you're doing transformations, you're going to follow your order of operations. So we'll work from the inside out. Anything that's inside with your x is going to affect x in the opposite way that it's written, and anything outside will affect your y exactly how it's written. So let me look at my equation, and I see that inside with the x, I have this -3. So I'm going to apply the opposite of that operation to my x's. So I create a new column over here for my x's, and this is going to be the column where I take my x's and I do the opposite of subtract 3, which is to add 3. So my new x's are 1 because I took -2 and I added 3. -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5. So these are my new x's, and I am now done with that -3. After we do our grouping symbols or our parentheses in our order of operations, we need to go to multiplication. So the next thing I'm going to work on is this -2. It's outside the grouping symbols, so it is going to affect the y, and it's going to affect the y exactly how it says it's going to. So -2 times y. So we're going to take all of our y values and multiply them by -2. And we're done with the -2. The very last thing we do in our order of operations is any adding or subtracting. So now I'm going to deal with this +5, which is again outside of the grouping symbols. So it's affecting the y exactly how it's written. So I take my -2y column and I'm going to add 5 to get me my final y values. So my ordered pairs are going to be the x from my first column combined with the y from my second column. So for example, my first point is 1, -3. I'll go ahead and list all these points and then we'll compare them to our last graph. So now that we've got our points, we just need to throw them in a coordinate plane and sketch the graph. But let me pull up our last graph so that we can compare the two. So the table from our first approach to graphing is right here. And if you notice, all of those ordered pairs are the same as the ones that are in the table. So I have this 1, -3. That's the first ordered pair in my table. 2, 3. 3, 5, 4, 3, 5, -3. They're all there in the table. So we got those same exact values, we just approached it a little bit differently, which means that however you do it, whether you do transformations or you find your vertex and then create your table from there, either way, you're going to end up with this being the graph of your parabola. Thanks for watching, and I'll see you next time. Bye.